In today's lesson, we're going to learn how to solve systems of equations by substitution. There are three methods, and this substitution method is going to be the second one we are learning through. So we have our first problem, which is y equals 2x and 7x minus y equals 15. Those are the two equations in our system. Let's go through the steps. Step number one says to choose the equation where the variable is alone. So that is going to be in this first equation here. The y is all by itself and it's equal to 2x. That's what it's equivalent to. Step number two is we're going to substitute the expression from the solved equation into the other one, then solve it. So that means that this 2x is going to replace where y is in my second equation here. Because again, I know y equals 2x, so I can substitute that equation or expression specifically into y here. And this is what it looks like. So what I did was I wrote my second equation here. Let's kind of back up a step. 7x minus y equals 15. And I erase y and replace it with what I know it's equal to, which is that expression of 2x. From here, step number three is to find the other variable. Well, we need to solve first, which is the end of step number two here. So combine like terms where they're on the same side. That's just 7x minus 2x, which is 5x. And then it's 5 times x. So in order to do separation of 5 and x, I must do division on each side of the equation, giving me x equals 3. This is when we go to step number 3. It says to find the other variable, we're going to substitute the solution that we just solved for back into one of the original equations and solve. So it does not matter which one you choose, but I'll choose the first equation here. Y equals 2x. Again, anytime you substitute, you erase and replace the variable you know a little bit more information of. Maybe it's a number, maybe it's expression, but you're substituting that in. 2 times 3 gets us 6 in the end. Write your solution as an ordered pair unless you have a special case, but in this case, since it's an ordered pair answer, we have an x value of 3 and a y value of 6. Remember, x comes before y when we write these in a point, and make sure you know your answer here. Let's go ahead and do another example. So again, going through the steps, step number one is choose the equation where the variable is alone. So y equals this expression here, and y equals this expression here. So both have y by itself. I'm going to choose which one I substitute in the expression from the solved equation into the other one. Let's go ahead and just do the first one here. So let's do our setup again. Y equals x plus 1. That's what y is equal to. I'm going to take my second equation and replace the y with the expression that I boxed up top here that I know it's equal to, which is x plus 1. That's what y is equivalent to. That's what I'm substituting in here. You always want to substitute the expression y is equal to into the other equation. From here, we go ahead and solve. So I subtract 1x on each side. That cancels out on the left, leaving me with 1. On the right, 2x minus a 1x is just 1x. Minus 1 gets brought down. Same thing with a positive 1 over on the left side. Now, negative 1, in order to cancel it on the right, I have to add it. 1 plus 1 is 2 on the left, and on the right, I just have 1x left, where x will be equal to 2 here. Now we go on to step number 3, which is substitute in the solution into either equation. I'll choose the second equation, which is y equals 2x minus 1. Erase and replace the x with what we know it to be, which is 2 here in this case. Solving that through, we do multiplication first, thinking about our order of operations, which is going to be 4. minus 1, giving me 3 here for y. Final answer, make sure you write it as a point. It's going to be x first, which was 2, and y second, which was 3 here. That's our finalized answer here. Now, I was saying that we usually write our answer as a point unless we have a special case. Did you end up with an equation that is a true statement, such as 3 is equal to 3 or 0 equals to 0? If so, this means the equations in a system are the exact same. Lines of the equations are overlapping each other, making it just look like one line. And all equations graph the same line. When you have all these instances occur, your answer will be infinitely many solutions. So that's what you would write as your answer instead of the ordered pairs we have been writing for our one solution. Did you end up with an equation that is a false statement, 1 is equal to 5? If so, this means the equations in a system will be not equal to each other. Lines of the equations are going to be parallel to each other. When these happen, you will answer with no solution instead of your ordered pair point. Let's look at some examples for these special cases. So for my first example, I have negative 4x plus 2y equals negative 6 and y equals 2x minus 3. So identify the equation that has a variable by itself. That will be this equation here where y is equal to the expression 2x minus 3. Once I know what y is equal to that expression, that's exactly what I'm going to erase and replace in the y of the equation where y is not by itself. So rewrite that first equation, which would be negative 4x plus 2y equals negative 6. And I'm going to erase y and replace it with what I know it's equivalent to, that expression in the box, which is 2x minus 3. What I go ahead to do is solve here by distributing first. Whenever I have a number multiplied outside my parentheses, I have to bring it to both terms inside, which will give me 4x and negative 6 here. Combine variables on the same side. Well, negative 4x plus 4x is just 0x, leaving me with negative 6 being brought down and negative 6 being brought down on the right. Well, when I have negative 6 equals negative 6, I think about what I had back on my last page of notes. Which of the following did I end up with? Well, I look very similar to 3 equals 3 or 0 equals 0. In this case, it's negative 6 equals negative 6. So that is a true statement, making this a infinitely many solution case. That's exactly what I write as my answer. Infinitely many solutions. Let's look at example number 2 here. Now, notice that y is not by itself yet, so I'm going to go ahead and solve for it to get it by itself here. So I'm going to take this first equation and just move over 1 away from y. That's the only thing that negative 1 that's stopping y from being by itself. So if I move it to the other side, y will be by itself. Add 1 to each side, cancels it out on the left, giving me y equals 2x plus 1. Remember, I cannot combine 1 and 2x because 1 does not have an x and 2x has an x. And that is now what y is equal to. So remember, that we see what y is equal to, and that expression of 2x plus 1 will be what I erase and replace my y with in the second equation. So I'll write my second equation that remains untouched as negative 2x plus y equals 6. And then I will erase y in this equation, substituting in what I know it's equivalent to, which is the whole expression of 2x plus 1. From here, I go ahead and solve, combining like terms on the same side. when they're on the same side of the line, you do the same operation they have in front of them. So that's negative 2x plus 2x. That gets me 0x. Plus that 1 gets brought down, and the 6 gets brought down on the right. I have this statement of 1 equals 6, which I know is a false statement, not true. Again, referring back to the last page, that looks like my 1 equals 5, in this case 1 equals 6, where it's not true. So I call this example no solution. And that's what I need to write. And I'm going to cloud my answers here, my final ones, because you will need to write them as your final answers. Cannot just leave it here for this second example at 1 is not equal to 6. You must conclude and write your final answer.